Welcome back, everybody. It's a lesson 4.3 about factoring quadratics. So in our first lesson, we were defining quadratics. We showed what it looked like when a quadratic was in factored form. So today we're going to learn how to put something into factored form and use factoring to solve some quadratics. So let's get cooking with factoring quadratics. So like I said, factoring is another method for solving some quadratics. So if a quadratic is factorable, and generally what we mean by factorable is that we can write the quadratic as the product of two linear factors. And a little bit more specifically, we generally consider it factorable if it can be written as a product of two linear factors that have integer coefficients and constants. So this example right here is an example of what a quadratic looks like in factored form. So just to show you that this is a quadratic, if we were to actually multiply this out, like we've done before, this is going to be x squared plus 2x minus 2. So this would simplify to x squared plus x minus 2. So this is the factored form of this quadratic. So you might be asking yourself, why is factoring helpful for solving quadratics? Well, if you remember back to when we talked about the quadratic formula, in order to use the quadratic formula, my quadratic had to be equal to 0. Factored form is also very useful if my quadratic is equal to 0 because I can apply this what's called the zero product property. So the question behind, or the idea behind the zero product property is when I have this in factored form, I have two things being multiplied by each other. If I have two things being multiplied by each other and the product of those two things is 0, the only way that can happen is that at least one of the factors must be equal to 0. So if I have this written in factored form like this, x minus 2 times x plus 3 is equal to 0, then there are two possible things happening here. Either x minus 2 is equal to 0 or x plus 3 is equal to 0. So if one of these two things happens, then this is the solution. So I'm going to say right here, x equals 2, x equals negative 3. So these are my two solutions to the quadratic. If either one of these things happens, then the quadratic is equal to 0 and I have solved for x. So that is the concept of the zero product property. If I have things being multiplied together and they equal 0, then at least one of the factors must be equal to 0. All right, so now the question becomes, now that I know what factored form is and why it's helpful for solving quadratic, the question becomes, how do I put something into factored form? So the first method that we're going to look at here is when a is equal to 1. So if we're looking at quadratic in standard form, if we're looking at ax squared plus bx plus c, the first method that we're going to look at is when a is equal to 1. So when this just says x squared. When this happens, what I'm looking for is I need to find two numbers that multiply to c and add up to b. So c right here is negative 15. So I'm going to need two numbers that multiply to negative 15 and add up to negative 2. So I'm going to list out my factors of negative 15. That's 1 and 15, 3 and 5, and then that's it. So I notice here that they multiply to negative 15 and they add up to negative 2, which means I can break this down into negative 5 and 3. So if I break this down into negative 5 and 3, then what I can do here is negative 5 is one of my numbers. So one of my factors is going to be x minus 5. Positive 3 is another factor. So my other factor is going to be x plus 3. And this is the factored form of this quadratic. If you are unsure, you can always check your work by distributing. So we'll do that here just to show what it looks like. So this can be x squared plus 3x minus 5x minus 15. So we got x squared plus 3x minus 5x minus 15, which gives me x squared minus 2x minus 15. So this first method is when a is equal to 1. I look for two values to multiply to c, add up to b. All right. And generally, this method of being able to just find those two numbers and writing those factors, you might also see referred to as the method of inspection, by just inspecting the quadratic and figuring out what numbers go in the factors. So method 2, when a is not 1, so if a is anything other than 1, then to factor it, this method of factoring is called factoring by grouping. So basically what I'm going to do is I'm going to start by taking a and c and multiplying them together. All right, so in this case, a times c is negative 24. So then I want to find two numbers that multiply to negative 24 and they add up to whatever b is. So b right here is 5. So I'm going to list out my factors of 24. That's 1 and 24, 2 and 12, 3 and 8, 4 and 6. All right, so I need to find a combination of two factors that will multiply to negative 24 and add up to 5, and that will be 8 and negative 3. So what I'm going to do with those two numbers is I'm going to break the linear term up into those two factors. So I'm going to break this up into 2x squared minus 3x plus 8 because the two numbers that I found here were 8 and -3. It does not matter which order you put them in right here. But the question that you should be asking is, why is it okay for me to just break this thing up? Because I don't want to actually change this quantity, right? But if this is 2x squared minus 3x plus 8x, if I were to combine my like terms back together, it would be 2x squared plus 5x minus 12. So I haven't changed anything. I've just changed what it looks like. And the reason that I've changed what it looks like is if I've done this properly and the quadratic is factorable, then what I can do is I can factor the greatest common factor out of the first two terms. So I'm going to go back. This was 2x cubed or 2x squared minus 3x plus 8x minus 12. So what you can do is you can take these first two terms and factor out the greatest common factor. So the only factor that these two terms have in common is x. So I'm going to factor x out and I'm left with 2x minus 3. These second two terms, I can factor out a 4, positive 4, and I'm left with 2x minus 3. Your goal here is to be left with the same thing in both sets of parentheses. Because if I have the same thing in both sets of parentheses, then what I can do now is I can factor this out of both terms, 2x minus 3, and then what is outside the parentheses, x plus 4, would be the other factor. So the idea behind factoring by grouping is I want to multiply a by c, find two things to multiply to a times c and add up to b. All right, break the linear term up into the two factors found in this step. So it's -3 plus 8. Factor out the greatest common factor. What is inside your parentheses, each set of parentheses is one factor. What's outside is the other factor. And we will look at some other methods for factoring when a is not equal to 1 that may be more helpful to you for now. The reason that I've decided to highlight factoring on grouping here is because this will also be helpful with higher order polynomials. All right, so these are a couple of examples that we're going to do in class. So if you want to, I'm going to leave these up here and let you try and factor these on your own. We already did both of these. Actually, yeah, because now you have to solve them. So I'm going to let you practice this on your own. If you need help, like I said, we already did both of these. If you need help, you can go back and look at the video and figure out what you did, but bring these to class. We will go through these together at the beginning of class. And that is it for today. So today we talked about the zero product property, how to factor when a is 1, how to factor when a is not 1, and then also how to solve quadratics by factoring. So if you have any questions, make sure you bring them to class. I hope you took some great notes, and I will see you in the next video. Have a fantastic day.